For some type of functions, you can use the quadratic theory to find the gradient of a tangent. Those functions are, for example, the quadratic function and the reciprocal function. You can see here the formula of both functions. So the quadratic function is y is equal to ax squared plus bx plus c, with a different than 0. And the reciprocal function, which is a rational function, but it's a special type, is equal to a over x, and a is different than 0. Let's start with an example. Let's do example 2. In example 2, they ask you to use the quadratic theory to find the gradient of the tangent to the function f of x equal to x squared at the point 1, 1. Okay, so the purpose is to find it algebraically, but let's sketch the graph first. So here we have the x-axis, here we have the y-axis, and it's a parabola which looks like this. Okay, and we have to sketch the tangent at this point here with coordinates 1, 1. Okay, so that will be this line, this straight line. And here we have a common point. Okay, but we have to find it algebraically. So the parabola, or the quadratic function, is y is equal to x squared. And we also have a straight line. Let's say that the straight line is equal to mx plus d. Okay, so here we have the parabola and here we have the straight line. So we have to find this common point, or where those two functions actually meet. To do that, we have to equate both functions to each other. So we replace the y here in the first function by mx plus d. So we can say 2 and 1, or 1 and 2, it doesn't matter. So that will give you mx plus d is equal to x squared. Okay. And then you can move everything to one side. Let's say we move everything to the right hand side. Then we will have x squared minus mx minus d, which has to be equal to 0. Okay. So this is a quadratic equation. We can solve this by using delta. And we know that delta can have three values. Like, it can be equal to 0, not three values, but it can be equal to 0, it can be greater than 0, or it can be lower than 0. When delta is equal to 0, then we have one solution. When delta is greater than 0, then we have two solutions. When delta is lower than 0, then we have no solution. Okay. In this case, delta must be equal to 0. Why? Because we must have one solution. So this quadratic equation must have one solution, or those two functions must have just one common point, namely this point here. Okay? Because in the case when delta is greater than 0, then we have two solutions. That means that this quadratic equation has two solutions. So that means that those two functions have two common points. And that is not the case here, because this is a tangent. Okay? And in case when delta is lower than 0, then we have no solution. So this quadratic equation has no solution. So those two functions have no common points. Okay? So to make this option clear, I'm gonna draw it on the graph as well. So two solutions. When do you have two solutions? When, for example, the straight line goes like this. In this case, you have two solutions. When do you have no solution? When you don't have any common point. So for example, this line, because there is no common point with the quadratic function. Okay? But in our case, the delta must be equal to 0. And when the delta is equal to 0, so when the delta is equal to 0, we know that x, so the x component, in this case is that one of the common point, is equal to minus b over 2a. That is the case because the delta is equal to 0. So this here is 0. So then x is equal to minus b over 2a. And the x-coordinate of the common point, it's given, it's 1. It's this one here. And the b is equal to minus m divided by 2 times a, and a is 1. So when I move the 2 times 1 to the left hand side, it's 2. And here minus times minus is plus. So m is equal to 2. So the gradient of the tangent, here you can see the gradient, is equal to 2. So that is the gradient of the tangent.